In this example, we're told that a force of 9 pounds is required to stretch a spring from its natural length of 6 inches to a length of 8 inches. And then we're asked to find work in two different cases. In the first case, when the spring is stretched from its natural length to a length of 10 inches. And then in the second case, from a length of 7 to a length of 9 inches. First thing we need to do is determine the spring constant using Hooke's law, F equals k times x, where of course k is the spring constant. And we're told that a force of 9 pounds is required to stretch the spring from its natural length, which is 6 inches, to a length of 8 inches. So x is 2. The difference is what we're looking for. X is 2. Remember, x is the actual distance that the spring is stretched or compressed from its natural length. So that's 2 inches. So k is 9 halves, and the units are pounds per inch. So here's our force function. F of x equals 9 halves times x. Part A, find the work done when the spring is stretched from its natural length to a length of 10 inches. Well, the natural length corresponds to x equals what? Now it's x equals 0. It's not stretched at all. What about length of 10 inches? What value of x corresponds to that? Well, that's 10 inches beyond the natural length, which is 6 inches. It's the difference, which is 4. So x equals 4. We're integrating the force with respect to x. Let's bring the 9 halves out. Anti-differentiate x, you get 1/2 x squared, running from 0 to 4. What am I using here? Well, fundamental theorem of calculus. Anti-differentiating and then evaluating the antiderivative at my limits of integration, taking the difference. So this is 9/4 x squared, running from 0 to 4. When I evaluate x at 4, of course I get 9/4 times 16. Subtract what I get when I evaluate it as 0. That's 9/4 times 0. 16 divided by 4 is 4 times 9 is 36, minus 0 is 36. What are the units? Well, the units of work, remember the units of force are pounds, and the units of length are inches, so this would be 36 inch pounds. Now what about the second scenario? It says find the work done in stretching the spring from a length of 7 inches to a length of 9 inches. Well, 7 is one more than 6. 6 is the natural length. So 7 corresponds to x equals 1, and we're stretching, what, to 9 inches? 9 is 3 more than 6, so x equals 3 is the upper limit. You don't have to put the x in the limit, but whatever. So we're integrating from 1 to 3. Same function. We've already determined that antiderivative. Why should I go through all that crap again? This is 9/4 x squared, running from 1 to 3. Plug in 3. 3 squared is 9 times 9 is 81 fourths. Oops, I'm off the out of the viewing rectangle. Subtract what you get when you plug in 1 for x. what is that, 72 fourths, which is 18. And again, the units are inch pounds. LBS. There we go. Not too bad.